Can you all see my presentations, my slides?
Yes.
Okay, very good. So this is a lecture 9, and last time we discussed about Qt GUI. We learned about meta-object compiler, signals, and slots, and we have seen a Qt project. And we answer some of your questions about Qt, how to install Qt. And we also learned a bit about threads, but this lesson we are going to first of all review what we have learned about threads, and then we will discuss about the details in some examples, through some examples. Then we will have a review over object-oriented programming. You already learned about object-oriented programming during this course, but from your projects, your first projects, when we evaluate your project, we noticed that most of you has problems. Have problems with object-oriented programming. Your projects were mostly functional, mostly written in a functional way, not in an object-oriented programming way. So we will review over that, and then I will tell you what you should send for your final projects. The last topic that you will see here, as I said in the last lesson, is serialization and deserialization. But we will not cover it in this lesson. I will just share the slides with you, and you can learn it by yourself. So threads, we said that, so we have learned about this part in the last lesson, but since I thought maybe I was too fast, and maybe for learning the next topics, you may need to have a review over these things. So that's why I'm explaining them again. So we said that a thread is a single sequence stream in a process. So a process can have multiple threads, and so for example, if you have a CPU of which has 10 cores, each core can have 2 threads. So your application at maximum can have 20 threads. It depends on your CPUs, how many threads you can have. And why we need to have threads? To make a task run parallel to another task, to take full advantage of CPU power and reduce response time, and to serve multiple clients at the same time. What does it mean? As I said in the last lesson, imagine you have a project which is a server client-based project. So in the server side, you are responsible to respond to multiple clients. So if you only have one main thread, you have to do you have to have a queue and respond them according to their time of arrival. So you have to answer, for example, the first request first, and then the other. So all the clients have to wait for the other clients to have their responses. So, but if you want to handle this one, you have to have multiple threads in your server side, and each thread will respond to each client, to the request of each client. In this course, we're not going to discuss about that one, but you will have some UIs, and in your UI, you cannot work only with your main thread to be able to have a good GUI. So you can also use threads for the other aspects, but it's mostly because you want to do some long processing time. You will have a long process like loading, filtering, and all of these things have to show through your GUI. So your GUI should handle all these long processes. So in that case, we will need threads. So for every long process in your GUI, you will have to run a thread. So let's go to the examples. And because my PC is Mac, and I to show you the examples, I have to share my other screen. Let's see, share content. Screen one. Okay, I guess you can see now my Visual Studio. Am I right?
Yes, we can see it.
Okay, very good. So let's see how can we use threads in ArcGIS. But just before that, let's review what that project is going to do. Okay, you have seen this project in the last lesson. So this project has two windows, one main window and the other one is second. It's just an example. It's nothing. I mean, because of that, the name of them are main window, second window, and so on. So the second window is just a window which is open, maximized. But we could open it in other ways. But the first window is in its default size, but the second window is opened maximally. So what does it do? It's I can write some things here. If I write anything here, you can see that this label is changing. You see the text in this label is changing. What does it do? What's it do? What it's doing is that we said that in Qt we have signals and we have a slots. So if the signals are connected to the slots will be run. So when I change something here, a signal is emitted. Every character that I change, if I delete or if any change that we make in this text, a signal will emit a signal. And that signal is already connected to a slot, which is responsible to change the text of this label. So this is the way that these two are working. I will show you the code behind that, and I will also share that code with you. The other thing here is if I press show message here, it just show me another message. So by changing this one, the message was your name is this text. By this one, the text is hello, this one. So again, this show message is sending a signal which is connected to this slot. So I guess both slots are the same or not. I don't know. We will check that. And this one is just a tool button. And if I right click over that, you will see a sub menu. A menu will be opened here with 4 different values. And if I check any one, you will see that Bahar is checked. Right click, Nassan is checked. So we will see the code behind all of these things. And as you can see here, if I press, there is a button here, show second. If I press show second, you will see another thing will open. I will show you how you can do these things. You see, these are the way that makes your, the things that make your GUI more flexible. And with browse here, you can open an image. Actually, in your project, last year we had this, but in this year I removed this part. So but I will teach you. I will teach you how you can also open an image, visualize an image. But in your final project, you won't work with any images. So what's this one is doing? I will F5. So I will open. I don't know what's the path for this one. Let's maybe here, store GUI, yeah, here. So I will select the folder. Inside that folder, there are some files. Let's open this one for you. My keyboard is far from myself. And so these are the files that are existing in this test data folder. I select this folder, and if I select that, I will see that there is a process running to load all these files. And I will see the changes in this main window. You see the progress bar, you see this one is disabled, and you see that if I can press second window, I can work with that without any problem while the other, I was too fast. Let's open it again. Sorry. System programming, store GUI, test data. So while this one is running, I can do any change here, and I can see the change. So it means that, this one is not, these two are not waiting for each other, because this one is doing, running in another thread, and this one is running in the main thread. So we will see that how can we work with threads in our projects. And show ID is just the thing that I explained to you in the last lesson. With this one, I wanted to show you how you can connect your GUI to your library. So when I share these files with you, you need to just go to this address to see how it was that. And you can also check the previous video lecture, then you will understand it better, because there I explained it in more details, and today we don't have time to review again this part, but we will discuss about the other parts. So let's just stop it. And so in main window, we have this button. This button, as I said in the last lesson, we have already in Qt, we already have some slots which are already connected to some signals. For example, for push buttons, we already have some slots whose name is on underline, the name of the push button, underline click. So this slot is already connected to the signal clicked of our push button. So I don't need to define any signal for that button to be able to use that slot. Or I don't need to connect these signals and slot. I will just write this here, and it's already connected. So if I go to the definition of this one, if I want to go to the definition of this one, I will just press F12. And this is the thing that you will see that is responsible to open the second window. So this is the second. I will show you this later. I want to first explain the other thing. Okay, let's first this one. This is the command link button browse. This is the button browse that we have just seen that. And as I explained again in the last lesson, we are just reviewing. Till now, we're just reviewing. We have seen that first, if I press this button, this slot will be on. And then it will check if the text, the caption of that button is canceled. If not, go to this one. If yes, go to this one. If so, go to this one. But first, let's see this. If the caption, so for us, it's not like that. The caption is browse. And it will use the Q file dialog, which is just a class in our Qt library, which lets us to open a dialog. And the caption of that, I set the caption to open directory. And I'm saying that the default path should be home. And it should only open the directories. As you remember, we just saw that when I opened that dialog, it only showed me the folders and not the folder content. And I had to open it from here, from my file system in Windows, to be able to see the files. So that's because of this one. Otherwise, you can just write here, for example, txts or any show files. I mean, show also the files. Then you will see also the files. But for here, this button was responsible to open a directory, and because of that, I put this setting here. You can go to the Qt documentation and see the other options that you will have for this one. So here I'm checking if the directory dir here, this is string. This string is the string, the path that has been chosen by the user when we open this dialog for them or her. So if the user press if the user close that dialog or press cancel, then the dir would be an empty string. So because of that, we will check if the dir is empty. If it is not empty, we will do the other things. If it is empty, we just cancel it. We don't do anything. So if the user choose any path, then we will create an object of type class QDIR with this path. And then this file has some methods. One of the methods is entry list, which we can set this one. We can give, it has 2 arguments for this example. It has 2 arguments, and with the first argument, I'm saying that I want to have only the txt files with any name. And I only want the files, not the folders. Okay, so it will give me the list of the files with these extensions, with this pattern. I could write anything here as well, but I'm saying that only give me the files with this pattern, whose name has can make this condition true. And then I will have the list of those files. Okay. If you remember from the last lesson, we created in the main window let me open it. One table view. I told you should work with table views, not with table widgets. I mean, the one that you can see, let me see here, not this one. And if you're working with this one, as you can see here, they are model-based, not item-based. Okay, so for these things, you have to create a model object. Okay, let's see. So this one is the model that I created for my table view. But where did I create that? F12 to definition. You can see that in MainWindow.h, I created a model of type QStandard item model QStandard item model, which is a pointer. Okay, where do I initialize that? In the constructor. As I said, always when we have pointers, the most common way to initialize, to construct them and to destruct them is in the constructor and in the destructor. So we allocate memory to mtable model in the constructor of this one, and we deallocate that memory using delete pointers in the destructors. Okay, so let's go to the constructor of main window. And I have a question here. This is what we are doing. Can you explain to me what's happening here? Can anyone explain what's happening?
A new model is initialized. But
A new
yeah,
model is, okay. What would be inside this table model?
I guess it would be a table containing info, but
I couldn't hear you well. Can you repeat?
I guess it would be a table containing info, but now it's just going to be empty.
Mhm. Just imagine I write here, okay, int, the keyboard is very far from int I, sorry, int star I, no, not int. We can also do int, but std string. You're familiar with this one, str, and new std. Oh, okay. What about this one? What will, because I thought maybe this is making you making it more confusing. What about this one? If I write a pointer of type string, what is happening here? Can you remember what new is doing here? What's the purpose of having new here?
With pointers, it's just, I thought that's how I remembered it. With pointers, it just creates them, but it doesn't let them point yet to a value, I think.
Okay, you are kind of correct, but not 100%. New is responsible to get a location of the reserve to get memory from our heap memory. Okay, if I write here, for example, a pointer like this, let me see. Let's see. I think it will happen with with a smart pointers in that case. But let's see, how can I, instead of new, I can. Okay, like this one. I will write this, and I will. Okay, it's very difficult. Instead of this one, we will have S, for example, and we will put just any text. Name, and this one, and I press S and str1, str2. Can you remember the difference between these two? No one remembers this?
I guess, yeah, with the second one, heap memories allocated, and with the first one, there's just a new one initialized, I guess.
Okay, I'm reviewing. I mean, these are not related to our lesson. I mean, to today's lesson. But I saw these mistakes in some projects, and I can't remember who was the person doing these mistakes. I think I gave the feedbacks, but I'm just reviewing these things for you to make sure that you know these things. With this one, we are getting memory from the stack memory. First, with this line, we are creating a variable in our stack memory. Okay, so it's not a pointer; it's just a regular. It's just a regular variable. With this one, we are getting the address of this variable. So, but this variable is in the stack memory. So with this one, we just see, we are just getting an address of memory, which is in the stack memory. So we are not worried about this one. This pointer is safe because it's only working with the stack memory. We don't need to delete str1 because it's in a stack memory, and then we know that the stack memory will be released when S is over this, will go out of this scope, S will be released automatically. But with this one, we are getting the memory from the heap memory. And now we are worried about str2 because after this one, this memory will not be released. We know that heap memory will be reserved for us. And so now it's very important to delete str2. I saw in some projects, people are using pointers when they don't need to use the pointers. If you are working with a stack memory, you don't need to work with pointers. Why we use pointers when we have large amounts of data and we don't want to use the stack memory. We want to use heap memory. And to solve the problem that we have with heap memory, that we have to be worried about that, we have to delete them. Instead, we use smart pointers. So we don't use smart pointers or regular pointers for our stack for our stack memory. We only use them for our heap memory. We work with heap memory only if we use new. Otherwise, using this one, this will not give us access to the heap memory. I'm still working with the stack memory. So pointers are different from memories. Pointers are just some variables referring to the memory, to some addresses in the memory. They can point to any memory address, either in the stack or in the heap memory. But if we work with the heap memory, then we have to be worried about our pointers. So these are the things that are important. So now I guess you can understand what's happening with here. Here we are getting a memory of type QStandard item model from the heap memory. And we are saving the address of that memory in this pointer. Yes, that memory doesn't have any value yet, but this variable has a value, and the value is just the address of that pointer, the address of that memory. So the pointers are not holding that memory, they are holding the address of that memory. So now, since I'm working with the heap memory, I'm worried about this one. I have to delete this one somewhere. Either here, I cannot. If I delete this pointer in the constructor, then I cannot work with this pointer anymore in the other functions. Okay, so what can I do? I can delete it in the destructor. This is the destructor. Here, I'm deleting this one and set it to null PTR. If I don't do this one, then that pointer is in somewhere. It will not be erased. So this is why I'm deleting them. Okay, is it clear? If you have any question, you can ask. Okay.
It is clear.
Okay, very good. So the next, so I said that we have TableView. Now we are working with that. For that TableView, we need to create one model, and that model is initialized in the constructor. You can initialize it anywhere else, but for my program, it was more sensible to have it here in the constructor. So then I will set the model of my TableView to this model. So any change that I make to this, if I change anything in this table model, that change will be shown to TableView to our table view. Okay, let's come back again to this one, to this function, which was the slot for our browse button. So I first clear that because as you saw, we may press that button multiple times and load different things. The browse button here in my example is responsible to browse any folder, and for the next time it will clear the previous one and browse the new one. So this is why I'm clearing this table model. And then here I'm setting I'm changing the status bar of my window, my main window, to loading files. As you can see, even in Visual Studio, we have a status bar here, and it says here ready. So the status bar is a place will show us the status of our program, our window. So there I'm saying that, okay, loading, before starting loading the file, I'm saying that I'm loading the files. The user knows I'm interacting with the user through these messages. I don't open a dialog to the user to let the user know what's happening. Instead, I will use the status bar. Then I will change the caption of the command link button browse to cancel. I will tell you later, just a few minutes later, why we are doing this. Then I will I will make the ProgressBar visible. What is ProgressBar? Let's go to its definition. ProgressBar is a cube, is a variable, is an object of type QProgressBar. QProgressBar is again a class in our Qt library. Okay, can you tell me where can I initialize that?
In the constructor?
Yes, of course. So it's similar to mtable model. We're initializing this in the constructor. So if you can see here, I'm doing that. Can you explain to me what's happening here?
Okay, I'm going to try again, but I hope it's correct this time. So now, since ProgressBar works as a pointer, and we use the word new, we make a pointer to an address where nothing is initialized but a little bit of heap memory is reserved for the value that has to be entered in.
Okay, very good. So 100%, this time 100% correct. Yes, as your friend said, this is just, I'm getting a memory from the heap memory with the type QProgressBar, and the address is saved in this variable. And for this one, yes, again, since I'm working with the heap memory, I'm worried about that, and I will delete this one as well in the destructor of this class. I can delete it anywhere else, but the common pattern is like that. So it depends on your usage. If for me it's like that, I'm going to work with a ProgressBar while the main window is open. So if the main window is closed, then I don't want to work with a ProgressBar. And because of that, when this main window is destructed, then I will delete this ProgressBar. Otherwise, I can delete it anywhere else. So I set the value of that to 0. The ProgressBar is just a ProgressBar, the green ProgressBar that we have seen while I was running the program. And so I set also the visibility of this ProgressBar to false, because I don't want to see that when the main window is open. But I will make it visible when a process is going to be run. And then I will add this ProgressBar to a status bar. So it will be located in the status bar. And let's go here. So as you can see, before loading the files, I'm making the visibility of ProgressBar to true. So before running this process, I will see the ProgressBar. It would be shown to the user. And what else? I'm also disabling the TableView file list here. And by doing so, it means that other functionalities of this TableView cannot be used by the user. For example, if we can click on every row of the TableView and do some task, with this one, I'm disabling that, so the user cannot click on the items of our TableView. But it can work with the other objects of my main window. If you remember, we had second window button. That one is not disabled. The other things are not disabled. The only thing that is disabled is TableView. We can also not to disable this TableView, but if we do this, then it would be more difficult to work with the threads, and I don't want to make it very difficult for you for your projects. But you should know that, I mean, it's not compulsory to do that every time. You can, you can just make it visible, make it enable, and then you have to handle all the complexities that it will bring up. Here I'm creating a thread. So till here, I was working in the main thread, similar to what we are doing in our in any things that we have done in our course. So it was main thread, but now I want to create a worker thread. If I write this one, then the worker thread will be run. And then the main thread will go to the next line and this line, and it will be run. So if the worker thread is not busy anymore, sorry, but the main thread is not busy anymore, because after that there is no commands, and so the main thread can respond to the user request. For example, the user can press second button, and the main thread can respond to that because it's not busy. But there is a worker thread that is loading the files, and that thread is busy. So let's see what will happen in the main thread. So in the worker thread. In the worker thread, I'm asking this thread just to run this function, sending this pointer and the text files to that. The text files is the input of load files. So here I'm with this one. This function is running in the thread, in the worker thread. So first, I'm setting the row counts of mtable model to the number of files that text file gives us. So we are setting the number of rows that we have in that table view. And as I just shown to you, that we have assigned mtable model to our table view. So any change that we make here will be shown also to our table. Then we also set the column of that to 1. In your projects, it might be different. So you may have multiple columns. You may have, so it's just an example. Here I'm creating a variable which has a portion. So in the progress bar, we are going to show a percentage. So how can we decide, how can we show the numbers? We need to define a portion, and we update the progress bar based on that portion. So the portion is here for us, 100 divided by text files.size. So text files.size gives us the number of files that we have in that folder. So It would be, this will give us the portion. I will set the CNT to 0. I will emit a signal, which is progress change. This signal is defined in MainWindow.h, progress change. It doesn't have any definition, just a signal. And when you want to define a signal, you only write to need. The only thing that you need to write is signals and a pattern like this, like a signature of the functions. You only need to write a declaration for that. But what does it mean? It means that it needs an input argument of type int. So I'm sending 0 to that. But what will happen? A slot should be run. Okay, this means that we need to connect this signal to one slot. Okay, let's see the slot. The slot that is connected to progress change is set ProgressBar. So I created a private slot with this pattern, but this slot should have a definition. And the definition is just one line, mProgressBar set value value. But why we are sending signals and slots instead of writing this line here, we could just write this line here. But the problem is that then we will make the worker there will be responsible to update also the main window. But this is not correct. First of all, the threads should be really separated from each other. For example, we have main thread, which is responsible to update our GUI, and the other one, which is doing some process, running some process for us. The other one, if we update them here, then there is no queue, and it has to wait here to have that change in the main window. So then the main window will be accessed through different threads. So then we will have Dataraces. But with this one, I'm saying that, okay, I'm sending a signal to the main thread, and the main thread, when the main thread has time for that, will handle this signal. If I change it here, we will have Datarace. And also it will make our GUI will be freezed because it has to answer all of these things, and it will receive many updates from this one, and the GUI cannot handle that. So this is the way that we can work with worker thread and main thread. What about this one? Okay, the next thing that we have here is that we have a loop over the text files. Just for the moment, ignore this line. This line is not something that you would write in your code. It's just something that I wrote here to sleep the thread for 2 seconds to mimic a long process. So you won't write these things, but you will have a long process here. For example, you are extracting, I don't know, you are creating objects here like that. So that is the thing for you, but you won't write this thing. The next thing that I'm doing is that I'm creating a row. I'm not creating a row, I'm creating an item, a cell here of type QStandard item, and I'm setting the row CNT and the column 0 to this item. So this item is just file name. It will has the file name as its title, and it will be assigned to mtable model. I will add an increment CNT, and I will emit progress change with this one. So CNT times portion will give me my progress, will show my progress. And then when this one is emitted, the corresponding slots will be run, and we will see the change in the progress bar. When all of these things is done, when we process all of these files, we need to emit a signal, which is finished loading files. This signal is again defined here, finished loading files. And if I do this one is connected. I didn't show you this, the connection part. So for progress change, it is connected through these commands to this set progress bar. And for this one, for finished loading file, it's connected to the complete loading slot. Let's see the definition of the slot. The definition of the slot is that, okay, the thread is done, the process is done, okay? We need to change the title of that to browse again because we have changed it to cancel. We need to make the table view enable because we disabled that. And we need to make the progress bar invisible because we visible that before running. We make it visible before running the thread. And we need to clear the messages that we had in a status bar. The message was loading files, and now we are clearing that. So this is again the way that we can work with our GUI and with our threads. The thing that I skipped was this part. What does it do? Let's see the example again, and I will show you what's happening. This is where you are connected to your library. You can just go to this part and to see it again. So I open this. As you can see, the title has changed to cancel. Okay, you can see the progress bar is changing. I can press cancel, and it's over. The thread is killed, not killed, but it's similar to that, and the process has been stopped, and then change has been changed to browse. Let's see how we can do this, because sometimes you have a very long process. For example, your user will open a folder of 1 million files, and it will notice that, okay, that was wrong. The user cannot close your application. The user cannot do anything. You have to let your user to cancel the process if it is a long process. Okay, so then how can we do that? So imagine we came here, we run this one, the text of that has been changed to cancel, and the worker thread is running. Then the user press the browse button, whose name is cancel now, and it will come here. It will check if the one that is the thread that is responsible to answer this one is the main thread, because this one, the worker thread, is busy with this one, and the main thread is responsible to respond this. So the main thread will come to here. It will see that the title of that is cancel. It will change the status bar to trying to stop loading data. So we are saying to the user that we are going to stop the loading data. And then here I'm checking if this thread, we created this thread here, we initialize that here. So we have access to that. I'm saying if it is joinable. What does it mean? It means that if the train is running. So if the train is running, then make this Boolean to true, and wait here till your thread will be over. Your thread will be terminated its task. But we cannot wait till the end. I mean, something should happen in in our worker thread to answer, to respond this request. Okay, let's see what will happen. First of all, mstop is of type steady atomic ball. What are atomics? Atomic objects, which we can use it for fundamental data types, makes our fundamental data types thread safe. So for these objects, we don't worry about if multiple threads have access to them at the same time. So that's why we are making them atomic. So these are thread safe. So let's see what will happen for this request. These lines are responsible for that. So for every run of my folder, I will check mstop. If this one is true, it means that the user pressed cancel button and the user asked to stop this thread, this worker thread. So if the user asks that, if the stop is true, then we emit finish loading files and we return. If you return this function, the thread will be over, will be terminated, because the thread is only responsible for doing this function. So this is the way that we can stop a thread and we can communicate between these two threads. Also, if you are destructing your threads, for example, I press loading a file and then I press closing the window. If we are going to close that window, if there is a thread behind, that thread will not be killed. If you close that window, it will close only that window and that thread will not be killed till it is running, till its end. So in the destructor, you're also responsible to stop your threads if they are running. So first we are checking if this thread is joinable, if it is running, then I make the mstop true and I wait here till this thread is terminated. So again, for this one, if the thread is running, it will check this one and it will be terminated. So this is how you can stop your threads. Is it clear? Do you have any questions?
I think it's clear.
Okay. So what else I want to say here? I think till here we said many things about threads. Let's see here some slides, and then we will come back again to these projects. Let's stop here. Stop sharing. Okay. Can you see my screen now? I mean the slides.
We see slides, yes.
Okay, very good. Okay. Till now, we didn't have any data races. We didn't have any data races. We were working with atomic balls. So and as I said, they are thread safe, and we also work with signals and slots. So we communicate with our main thread like that. We didn't change our GUI. in our worker threads. So everything was totally, the data was totally separated between the main thread and our worker thread. So because of that, we didn't have any problem. But this is not the case for your project and for many projects. So what is a data race? A data race occurs when two instructions access the same memory location. At least one of these accesses is a write. So if we have two processes, both are reading from the same location, we don't have any data races. That's fine. But if at least one of them is writing in that location, then we have data races. So don't use mutex and so other things, some other things when you have when you are only reading from them, when you only have processes that will read together from that location. But if there is one process that is possible to write at the same time that you, in other threads is reading from that location, then you have databases, then you have to deal with that. What are the solutions? There are different solutions for that, but in this course, we are talking about the most common solution. You can go for yourself and read more about semaphores, barriers, latches, and so on. But for this course, you only need to know about mutex and atomics. What are a mutex? A mutex, mutual exclusion, allows us to encapsulate blocks of code that should only be executed in one thread at a time. We will see one example of that and you can understand that better. And you are already familiar with atomic types. Objects of atomic types are the only C++ objects that are free from data races. But you cannot use atomics for vectors. I don't know about C++2NE, maybe, but in other compilers, you cannot use atomic types for example, for vectors, for the other objects, only for fundamental data types like int, bool, and so on. So let's see an example of data race. We have an object, a class of type students. That class only has one data member, which is MScore of type float. We have a getter and a setter for that one. In this example, I wanted to have a getter and setter, but it doesn't mean that you have to always have getter and setters. You will define a setter if you want to change that. You will define a getter if you want to read that. And so we have, we want to, in our example, let's see first this one. We are going to have a vector of shared PTR students. And I'm adding, creating some instances of that students, a shared PTR of that and push back to the students. So we will have 6 different instances in these students, and every of them has the score of 0. This is in our main thread, okay? And then I will have a worker thread which will do a process compute a score for us. It's a function that you have seen in the previous slide. I will come back to that. And in the main thread, after this line, after creating this thread, it will immediately go to this line. First, it will wait for 3 seconds, and then it will continue. So it is again, with these sleeps, these are not something that you will write in your program. These are just something that I wanted to say that, okay, I have some lines of code that will take 3 seconds to be run. So this is just something that will mimic that process for me. But it doesn't mean that you will have to write this. You should not do that. And then the other lines, which is, so it means that we will do something, the main thread will do something, and after that we come to these lines, which is iterating over the students. Skip this line for the moment, and it will get the scores. So the main thread is reading from the students, is reading, is not changing anything, just get the score. But what about compute score here? Let's come back to the previous slide. In this one, which we want a thread run this one, we are passing the students, and we are iterating over the students. And as you can see, again, ignore this line. As you can see, we are setting, we are changing the items squares, item scores. Okay, so this one, which will be run in the worker thread, is changing the items. Someone is writing in this data, but this one is reading. And we said that if we have at least two threads, that at least one of them is writing, then we have Dataraces. So here we have Dataraces. So if one of them is writing in that location and the other one is reading, we have a data race. We don't know, I mean, the process doesn't know what should do. I mean, we don't know what would be the results. So we will have an access violation error. So how can we solve this? Okay, we can use Mutex to solve this problem. So first we define Mutex. I didn't write the definition. Yeah, here. In our all of these example is written in main.cpp. Okay. In your project, it won't be like this. You will define, for example, this one in, you will see in the next slides. But in this example, it's all of the things are written in the main.cpp. So this one is defined in the same scope as we defined compute a score, as we define a student, and as we define, we wrote this line. So all of these functions, these commands are written in the same scope. So we define a mutex of type, a variable of type mutex, and we write a scope here. This in C++, we can define a scope just by two braces. Okay, so we define a scope here, and I'm saying that lock this scope and ask for this mutex. If this mutex is available, then run the next line. If not, this worker thread will be asleep. The operating system force this thread to be asleep, to sleep. Okay, so the thread will be asleep. And if the mutex is another thread using this mutex, so at every time, at every moment, only one can have this mutex. Okay, if this mutex is gotten by another thread, then this thread has to wait for that because it doesn't have any key to enter this scope. Okay, it's like that. So, but if it is not like that, it will go inside, run this one, and after this scope, it will release that mutex. So after this, any threads that are waiting over this mutex can get this mutex and go and do the next process. So imagine here in this one, I mean, in the main thread, I was reading from that item. We also had a lock here. We also have a lock here. This again asking for the same mutex. So if the thread the worker thread has this mutex, it means that it's changing the data. Okay, so I cannot read this one until the moment that mutex would be released by the worker thread. Then it means that the writing is over and I can read that. But there is a problem again here. First of all, every time that we are accessing to item, we have to write these lines of codes, which is really ugly and which is really prone to errors. Because maybe and you have a colleague or even yourself, after a while, you may forget that there is a data race here. And you just write it and you think that, okay, it's okay, I don't need to write anything. But that's a problem. The other thing is that, I don't know if I can ask this from you or let's see the other problem. Okay, let's first, I don't know if it is too difficult to ask. Okay, I will tell you the answer, and then based on the answer, maybe you can guess the second problem. So the first problem, we said that, okay, it's difficult to write these lines every time that you want to access these two. And also it's very prone to error, but there is another problem with this one. But let's see the solution, and then I will ask you if you can recognize the problem, the second problem. So what is the solution for this one? We can solve the data race inside the object. So what does it mean? We can define mutex. We said that mutex and every codes that we had in the previous example has been written in the same scope in the main.cpp. Okay, but here we are saying that, okay, let's have a variable of type mutex in the students class and make this object thread safe, make this student thread safe. What does it mean? In the set a score and get a score, I'm writing this one. I'm calling this the mutex. I'm asking for the mutex, and then I will change that. So these two cannot be done at the same time. The only thing that then you need to write in the worker thread in this function is similar to the previous times. Then we don't need to write any scope like anything, because inside the set score we already wrote that we already asked for that mutex, so we don't need to write anything here, and it's asking for that mutex. Okay, and here in our main thread again, I'm get the score, and I don't have any problem because item object, this object will use its own mutex for if you are going to access that, if you are going to get or set it. Can you see the difference here? And can you guess the other problem, the difference between why we define mutex in the whole scope, and we call it for every item like here, and the difference between this one, and when we define mutex instead of here, we define mutex here, and we call it inside that. It's related, again, another hint, it's related to have objects, and can you guess? It's a bit difficult, but can you guess?
I have a hypothesis. So when we go to the first idea of just doing it in the function, not in the object mutex looking, The problem with threads is that it's you can't really be sure when a thread is frozen and the other one begins. So let's say a thread is frozen right after the locking of the data happens. So right before get score. So right before the function that's going to happen. So then it's the turn of the other one, and then they're just busy waiting.
No, that's probably not. It's really good that you're thinking about these things. It means that you're understanding them. But you know, the scenario that you are saying is that, for example, the worker thread here will be over, but the other one is waiting. Did I get you correctly?
No, what I try to say is not that it's waiting, but that it would be waiting for nothing. Let's say on this slide, for example, if the thread freezes between log data and std cout item gets core. If it freezes between them and then it goes to the other threads can enter the mutex because it is locked, but the other one wasn't really using it yet. So it's just waiting.
You know, if it's not using, for example, it's come here, the main thread is come here and it's waiting. I mean, the only reason that it has to wait is that the other one, which is this one, oh, sorry. The other one, which is this one, is here. So it already has the mutex. But if it is here or here, it means that the mutex is released, and this one will not wait. It go to the next line. Maybe I don't get you. I don't know, because it's not I mean, the thread will not wait unless someone has the mutex. If the mutex is not assigned to anyone, then this thread will not wait. Am I clear?
Yeah, yes. I think the thing is, the problem that I'm describing is just will just amount in waiting for nothing, but it's not error breaking stuff. So
it will not wait for nothing. I mean, okay, we can say in some scenario this is really bad, that you may do something here. For example, you may write here a while infinite loop. If you write an infinite loop here because of a bug that has happened to your code, then the other one has to wait for for nothing. You know, the other one will also wait because this one will never release that mutex. So in that case, yes, the other one has to wait that. But the thing that I was asking was not this. Let's explain it more, and maybe you can guess it after. Here, this mutex is using for all of these items. What does it mean? For example, if I come to here, I'm iterating over the student's item. I'm changing the first one and then the second one. No one asking for this mutex yet. Okay. I'm on the third one. I'm changing the third one, and the other one, which is this main thread, is going to read the first one. But even if I'm not changing the first one, the second one, I mean, the main thread has to wait for the second, for the worker thread. The worker thread is changing the third one, but I have to wait for that one because the mutex is the same. Can you understand what I'm saying? No one?
Yeah, so instead of making one mutex for well, I would say for the main file, you make one mutex per object.
Yes, the problem is that the mutex is shared for all of them, and we don't know which item is changing, okay? And to be safe, we are using the Mutex for all of them. While the data that we need to be worried about, that is that if we are changing the first item, we should not read from the first item, but we can read the next items. We don't have any problem with the other items, okay? But with the second solution, the one that we have here, we will see about more, we will review object-oriented programming, and then you will understand this better. We are only calling these mutex on the objects themselves. What does it mean? It means that, okay, this mutex belongs to the instance of students. It is not shared between all the students. We created here 6 different students, okay? But all the different students were, to access all these members, we use the same mutex. But here, for every student, we will use one mutex. So this means that we have 6 different mutex, not one. So with this one, if I call item StatusBar, item is an instance of the students. It has its own data member, and that mutex is its own its data member. And with this one, we are waiting over that mutex. So if it is the item, the first item, we are waiting over that mutex, okay? If in this computer score, we are waiting over the mutex number 3, mutex of the third item, and here we are reading from the first one, this mutex is not allocated, is not assigned to anyone. So there is no problem, none of them will wait for each other. They will do their task because this one is before the other one. This one is reading the first item, but the other one is reading the third one, is writing to the third one. So this is another advantage of making your object thread safe. So is it clear? No?
I think it is.
Okay. If you have any question, you can ask. It's a good way to discuss to different scenarios. I mean, defining different scenarios helps you to understand these things better, as Sam has just done. It's really good because when you think about different scenarios, you can understand them better. Okay. The last thing that I want to tell you about threads are condition variables. Sometimes you have different threads that we saw that we join, we can wait for a thread till the thread will end, okay? But sometimes a thread is responsible to do multiple tasks, and the other thread is going to do another task based on the results of the other threads, the mid results of the worker thread. So if this thread finish this process, the first half of the process, if suppose it's 2 parts, if the worker thread finalize the first half of the process, we need to notify the main thread, and the main thread will do the other things. So the main thread will wait till the worker thread will notify it, okay? So in that case, we need to work with condition variables. It's not only for 2 threads, it can be between 1 or more threads, wait for another thread to finish process something, okay? This is our worker thread. Again, it's just an example. So we have all of these things again written in the main .cpp. We have a mutex. We have a score computed, a condition, atomic Boolean. We have a conditional variable. We are saying here, okay, let's compute the scores, and if the scores computed, then notify one thread. We can also say notify all the threads that are waiting for that. So again, for this conditional variable, we need to use a mutex. We need to define to set a Boolean to true. These are along with this conditional variable. Both of them are necessary when you are working with conditional variables. And then in the main thread, like before, I'm creating 6 different instances, and then I create a thread, and inside the main thread, I'm waiting over this conditional variable, and I'm saying that, okay, don't do anything before getting that notification. So I'm checking here MS score computed. Why? Because if we only wait for the conditional score, it may be, I mean, the worker thread may notified already, may be over already, has done the first part of its task already and notified, and I didn't get that notification. So then I has to also work with a conditional work with a Boolean here, okay? And so because of that, I will check that. And why it is a while, why it is not if? Because in some operating systems, all of the mutex conditional variables, all of things are just some operating system level commands. So for example, you can implement mutex yourself with some Booleans, but then you will have to make your CPU busy with that. But with mutex conditional variables and so on, the operating system is responsible for that, and your CPU will not be busy with these things. So, but because of that, operating system may have some problem. You may not get that notification, and so it's important to make that safer with having a conditional variable next to that. So if this one is not true, we wait over the conditional score. If not, we will go over. Even if I didn't get that notification, I will go after that. I mean, go to the next one. So we call this process missed wake up. Because of that problem, we use this variable as well. I don't think that you will need to work with conditional variables in your project. Maybe based on your design, you may need that, but I guess not. But this is something that, since it is very common, I wanted to share with you. And what else? I think I said all of the things. If everything is clear, we can go and have a review over the object-oriented programming. Do you have any question?
Not as of yet.
Okay. So you have just seen the one benefit of our project, our solution, that I said that, okay, if we define mutex inside the class, this means that it belongs to the object, and you saw the effect. But if you don't understand what objects are, then you cannot implement your projects based on, I mean, in an object-oriented way. So you will write everything in a functional way, and you will not get the benefits of object-oriented programming. I already explain all of these things that I'm going to explain to you. But since they were separated from each other in different things, in different lessons, I saw some mistakes from you, from most of you, in the first in your first project. So I decided to have a recap over the object-oriented programming principles. And if you have any questions, you can ask, because these are really important. These are, if you are writing a code in C++, in Java, in Python, you should write your program in an object-oriented programming way. And if you don't do that, it means that you are using, for example, C language, not C++. So what is OOP, or object-oriented programming? First, let's see what's functional programming. Writing procedures or functions that perform operations on the data, it means that we have functional programming. So you only have some functions and some procedure that are working with some data. And I saw some of you are doing really like that. Some others, I saw some of you you have some classes, but you are just creating one instance, then throw it away. One instance, throw it away. And I don't know if you are going to erase that object immediately after creating that. Why you should create an object? You will go for functional programming. You know, if you are going to have object-oriented programming, you should keep them somewhere. I'm not saying that you should keep all of your objects in your memory. No, you cannot keep all of your objects. But it doesn't mean that if you cannot keep all of them, you cannot keep any. So so you, for example, you can release the data inside your objects instead of erasing the whole object. Yes, sometimes we have to erase also the objects. For example, when I load some files, create some objects, I will clean, for the next time that I was loading them, I will clean all these objects. I will erase all of them. But as long as I'm working with the same data, I will not clean all the objects. I will not delete all the objects. I will not destruct them. I mean, what I do, I will destruct, I will erase the data that they include. Some of their data, not all of them. For example, in your project, you can keep the data in from their file names, but you can delete the data from their file content, but you won't erase the whole objects. But if I load another folder, another data, yes, in that case, you will erase all of them. This is object-oriented programming. Object-oriented programming means creating objects that contain both data and functions. So it has some objects that can have data and some methods, data members and function members. The advantages of object-oriented programming over functional programming are these things. OOP is faster and easier to execute. As you can just saw, if we just go for functional programming, as you have seen, we had to wait for all of these Mutex. We had to wait for all of them, even if it was not compulsory. We could just keep those Mutex inside the objects, then no one has to wait for them. I mean, only if both of them, if we access to the same object at the same time, then we have to wait for that. Otherwise, we don't need. But if we go for functional programming, we don't have this ability. We have to wait for all of them because we are not working with the objects themselves. I mean, these are the meaning of it. You cannot say that, okay, I have a classes here. It means that I have object-oriented programming. You will see in the next slides what's the difference between classes and objects. You should in your whole program should be implemented in an object-oriented way. You cannot say just having a class means that your program is object-oriented. Object-oriented programming helps to keep the C++ code dry. What does it mean? Don't repeat yourself, and makes the code easier to maintain, modify, and debug. So we don't like to repeat our codes. I saw from some of you, you just copy one function to another class, one function to another one. We don't like this. If something is going to be used in multiple places, we write it somewhere and we use it from there in different places. So don't repeat yourself. Why? Because if you want to change something in that process, you have to go to every location that you copied and then change them. And it's very prone to error. And you are just making your code very long. I remember from my experience from the past, I've heard from some students that they are saying that, okay, I have 1,000 lines of code. But what does it mean? It's not that it's not something that you should be proud of yourself if your code is very long. You can make your code shorter, not by deleting the enters, by using functions, using object-oriented programming. OOP makes it possible to create full reusable application with less code and shorter development time. So let's see that what are classes and the objects. For example, we have classes like student and teacher. You saw some examples like this during this course. We had employee, students, teachers, and so on. So we have the students, it's just a template for our object. It's not an object. A class is not an object. The instances of that object, that class, is an object. Okay? For students, if we define a class of type of students, this one is a template, and the instances of that, for example, we use the constructor of a student, we create some object with these names, Ariana, Jonathan. So in this case, these are the objects. These are human beings, little human beings. But for our examples, they will be the objects of our classes. We have teacher, for example, and this is a class, and the objects that we create from them using the constructor would be our object. The instances would be our object, Nassar and Adrian. But if I create them, I should keep them somewhere. We cannot just create an object because we want to use their functions. They should have one. They have some identity. You know, they are something. As I give this example to some of you during the evaluation day, I told you, for example, when we create a refrigerator in our real world, every time that we want to use it, we don't create them and throw it away. We create that, we use that. The next time that we want to use it, we use it again, the same object. We don't recreate that. So your programs are really like real world, how you work in real world. It should not be like throw them away. For example, if your refrigerator is too heavy and that you cannot handle it, okay, you will throw some items from your refrigerator away, but you won't throw your refrigerator away because you don't have enough time. It's very expensive for you. This is also the case with your objects in your program. It would be very expensive for you, either in because of the time complexity or because of the memory. You cannot throw them away. So that's why but for example, for the refrigerator, if I want to buy a new refrigerator, yes, I will throw the first refrigerator away. I will buy it, for example, I will sell it. But if it is corrupted, okay, I will throw it away, but not always. So I'm repeating all this for these words more than the previous time, again and again, because I hope that I won't see those mistakes again in your final project. So what are the principles of object-oriented programming? Encapsulation, inheritance, polymorphism. This is the first thing that I taught to you in the first lesson. We also have abstractions. If you go to some tutorials, you will see that they are talking also about abstraction. But in some others, which I mostly like them, I like them the most, are defining only encapsulation, inheritance, and polymorphism. To me, these two are the same, are very can be defined together. You don't need to separate them with each other because it brings up more ambiguity. But if you heard that, you should know that, okay, with my explanation here to you, you already are doing abstraction as well. What is encapsulation? The meaning of encapsulation is to make sure that the sensitive data is hidden from the user. So those who use those projects that were only using the public data members were not object-oriented programming. Okay, they were not encapsulated. Your objects were not encapsulated. So to achieve this, you must declare class variables and attributes as private. This means that it cannot be accessed from outside the class. If you want others to read or modify the value of a private member, you can provide public getter and set methods. You have to define getter and setters, but not for all of them. Only the ones that you want to modify or you want to read. You may also want to only read from them and you don't want to modify them. In that case, you will only write the getter, not the setter. Let's see one example. For example, we have a class whose name is car. The attributes such as color, year, model will be private variables. They can just not be changed by other objects. So we don't do that. But if we want to change something, for example, if we want to change the color, then we define a setter for that. But if you want to, for example, read the year and model, then we will define a getter for them. The start method. For example, the car class may have a start method, and it may have some code inside it, which provides what happens when the method is called. The object calling that method does not need to know how it works or what code makes it work. The only thing that it needs to know is that it works. Okay? So don't share your code with your with the user of your class. For example, and it will be done in different levels. Encapsulation is not only in the class level. For example, in your library, in your GUI, we had to define an interface and we only shared the interface with the GUI. Or in the in our classes, we may make a function public, but that function may use other functions, but we don't make those functions public because the user is not going to work with them. We make those functions private because only We will only access them in that class. Okay. Inheritance. We have similar objects. It's very common to happen. They can share some code or logic, but they are not exactly the same. Creating a brand new class for every object we use in our program leads to more code and complexity. So with inheritance, we extract the logic in one object. For example, we call that parents to another object called child. So inheritance enables us to use a parent object to define a child. You are already familiar with inheritance. So this is another thing why we have inheritance, but we should use that when there is a logic behind that, when it is really necessary, when it is really useful for our program. So this is why I wrote in your project definition, you should use this concept in an excellent way, in an efficient way. So I don't want you to, if you remember from your first evaluation, mostly we didn't ask you to run your program, but this is not the case for your second project. We will ask you to run your program as well. But we were most curious about how you used your these concepts. If you really understood what these concepts are. So these are most important. These are really important to you because if you really learn these things, then learning another language will be very easy for you. Running working an application, writing an application that will run is not your goal. If you make this your goal, then you won't be a good programmer. You won't write good programs. Your programs will be prone to bugs. Your program will be very difficult to read, will be very difficult to be upgraded. You will have very difficulty to work with other colleagues. So these are really important, much more important than if your program can works or can run or not. So the example of inheritance, we can extract the features like year, color, and model from the car, and we can define other classes of type trucks, buses, and vans, which have the same features by inheritance. So we don't define these things again for these classes when we have inheritance, because we don't want to make our code dry. Don't repeat yourself. I mean, we want to make it like that. Sorry. So the last principle of object-oriented programming is polymorphism. So with polymorphism, child might have a different way of implementing a method. So polymorphism gives us a way to use an object exactly like its parent, but keeping its own methods as they are. So for example, if a car has a start method, it may be implemented, but by each child object differently. So the child class can override start method from the car class when there is an inheritance. If you cannot remember, go to that lecture I talked about overriding, overloading. I talked about virtual functions, and so on. So these are and also I talk about polymorphism by assigning a pointer of type child to a pointer of child parents. So go to those concepts and review them. So polymorphism enables each child object to implement the start method differently. So you have one object that has different forms. This is the concepts of polymorphism. So is it clear now of what object-oriented programming is? Do you have any question? Okay, everyone asleep?
I don't have any questions about this as of yet. I think I understood it.
Okay, very good. So what should be sent as your final project? This is something that I already showed to you. So delete these things. Really, if this time I see a project which is 600 gigabytes, I won't download that. I will ask you to send it again. So delete these things, and also this one and this one. If you delete these things, your code will be less than 50 megabytes. It will be very small. And how you can send it? Send it through OneDrive. VUB gives all of us a OneDrive account, so you can use that and send it to me. Don't use W transfer or something like that, because I'm not sure that the moment that you will send your project, I have time to download that, or I'm using the same PC, or I'm busy with other things. That then if you send with those things, I mean those services, then I cannot download that because they will be expired. Then I have to send another email to you and ask you to send it again. So share it with OneDrive, then it will be there till the moment that I can download that. And which email address that you should share with is this one. And it would be great, if you can also change the subject to this one. It's not compulsory. It's okay. I can find it. But if you can also change the title of that to final project, your name, and if you are electrical engineering students, write electric EE, and if you are biomedical engineering student, write BE here. So these are the all things that I wanted to share with you. And after that, I will also share the files. I won't send you the whole projects that I was sharing with you today. I will send the whole files, but not project files. Because if I send them to you, then you won't create any DLL or any GUI for yourself. But so if you create a DLL and GUI for yourself and add these things to your project, you can run the program. You won't have any problem. So the code will be shared with you, but the projects not. Use them. I think most of the things that you need to know are taught, and you can use them to have the code and to write to your final project. Do you have any questions about your final projects? Are you there? Can you turn on your camera, all of you? I want to see who are here. Okay, 2%. Oh, all of you are here and listening. Very good. Okay, not all of you. Some of you are absent, but it's good. Okay, if you have any question, you can ask. No question about your final project? You're doing that very well. Have you started doing your final project? Not yet. Okay, the deadline is 13th of May. Okay, if you don't have any question, we can stop the lesson. But if you have any question, you can ask.
Did you say 13th or 30th of May?
13th. Yeah. No, don't worry. Actually, I could give you more time, but since the electrical engineering student is going to give their present their projects at 4th, we have to be fair with all of you. And I usually ask the students to send their project 1 week before their presentation, but I try to be more flexible with you, and I gave you only 4 days before your presentation. The deadline is 4 days. Yeah, 3 days even. I have only Monday, Tuesday, and Thursday, I think, Wednesday to read your code. Okay, don't worry. You have enough time to do that. You already did most of them. You only need to create a library, put your code there, correct yourself based on the feedbacks I gave to you, and write the GUI. And they don't try to make your GUI very fancy, just like the GUI that I shared with you. It should not be very fancy. Okay. Okay, have a nice day, everybody, and good luck.
Thanks.
Bye.
Bye.
Record.